Okay, so again, welcome to another day for learning Linux. It's day three, and today we will be learning some newer topics that even I don't have any idea about. So what I have known, I have already discussed it in last two live, and now I will be learning by myself too, as well as I will try to revise it by teaching to you guys. So that is how I learn. I first of all learn by myself, then I try to teach it. And when I try to teach it, I would revise it. So now, first of all, let me take my note and this. Now it's day three, right? It's day three, and now we are in another level of Grasshopper in the Linux journey. So we will be learning about these thing, and I have just practiced a little bit about this. Didn't go as deep as I would go now, but still, let's start the game. So first of all, it says std out, standard out. As we continue to learn Linux, we've seen how commands produce output. This brings us to an important topic of I/O streams, especially standard output or std out. Let's explore this concept by running the following command: echo hello world arrow peanuts.txt. After running this, you will find a new file named peanut.txt in your current directory. If you view its contents, you will see the text hello world. Let's break down what happened. Understanding standard output. First, consider the command without the special character. Echo hello world. By default, many commands send the result to stdout, which is your terminal screen. This is why echo hello world displays the text directly in your shell. Processes use IO stream to receive input, standard input or stdin, uh, and send output. IO redirection allows us to change this behavior, giving us greater control over our data. Redirecting std out with arrow. The arrow character is a redirection operator. It intercepts the data heading to std out and sends it to a new destination. In our example, it sends the output of echo hello world to the file instead of the screen. If the file doesn't exist, it will be created. Be careful, as if the file already exists, the operator will completely override its content, appending std out with double arrow. So I know about it, so there is no need to discuss. Let's go to std in standard in. In our previous lesson, we learned about redirecting the standard output stream. Similarly, we can also manage the standard input stream. By default, our program receives its stdin from the keyboard, but we can also use files or the output from other processes as an input source. Understanding std in and standard out. Every command line process in Linux operates with at least two fundamental data streams: standard input and output. A program reads the data from stdin and write its result to stdout. Understanding how to control both stdin and stdout is crucial for effective command line work. How to redirect stdin. Just as we use arrow for stdout redirection, we use the arrow operator to redirect stdin. This powerful feature allows you to tell a command to read its input from a file instead of waiting for you to type it on the keyboard. This is a core concept of input redirection. Practical example with cat stdin. Let's revisit the peanuts.txt file from the previous session, which contained the text "Hello World." Consider the following command: cat peanuts.txt banana.txt. So what you will do that peanut.txt have "Hello World," right? So "Hello World" will it will copy the text from peanuts.txt to banana.txt, but I am confused why we are using cat right here. Okay, so cat shows the oh, it shows the output from a text, right? So here's a breakdown of what happens. The arrow peanuts.txt parse the shell to redirect stdin for the cat command, making it read from peanuts.txt. Okay, so what it does is, so let's take this. Okay, so now what it will do is it will print. So it will print the text from peanuts.txt like cat does, right? Cat always does something like cat text file, and it will print out the content, right? And that content will get stored into banana.txt. But the thing I don't understand is we don't need this, I guess. Let me just try it. So if I want to try, what will I do? I will, unless, okay, so I already have this. So what I will do is like I will remove rm banana txt rm peanut.txt. Okay, so let me create a new one. We will create a peanut.txt, right? And we will add some content here. Hello. Okay, now it will go to the peanut.txt, and now we will write the same command but without that particular arrow button, banana.txt. If I click enter, okay, so now if I try to see what's inside it, it prints hello. So there is absolute no need to use that output stream thing. You don't need that. Let me hide this. Okay, anyway, now we don't need this, to be honest. Now let's go to third one, which is stderr. Let's explore what happens when a command produces an error. Try to list the contents of a directory that doesn't exist and redirect the output to a file named peanut.txt. It says instead of a clean prompt, you will see an error message on your screen. ls cannot access no file of directory. And you might be wondering why this message wasn't sent to a file. This is because another IO stream is at play, which is standard error. So if I have to write how many standard stream are there, so there are three standard stream, which is stdin, stout, and std error. Okay. In std error is a default output stream used by the program to send error message and diagnosis. It is completely separate from the standard output stream, which is used for normal program output. By default, both std out and send the output to a terminal screen, which is why you see the error directly in the terminal. To control stderr, you need a different redirection method. Understanding file descriptors to manage I/O stream like stdin, stdout, and stderr. The system uses file descriptor. A file descriptor is a non-negative number that the kernel uses to identify an open file or stream. The default file descriptors are stdin, stout, stderr. The number 2 is a dedicated file descriptor and we can use it to control where our error messages go. Redirecting stderr to a file. To redirect stderr to a file, you use the file descriptor 2 followed by the arrow operator. This command will send any error message into a specified stderr file. Now your terminal will be quiet and the error message will be seen inside peanut.txt. Command stdout and stderr. What if you want to capture both normal output and error message in the same file? You can achieve this by redirecting both streams. And how will you do that? It says peanut.txt. So this is an error, right? This is an error, and it will pass the output error message to peanut.txt. And this part, let's see what it does. Peanut redirect std out file descriptor 1 to the peanut.txt file. 2 redirects stderr file descriptor 2 to the same location that std out file descriptor 1 and is currently pointing to the order is important to send stderr to the current direct destination of stdout in case stdout is pointing to a file, so stderr is also sent by that file. A more modern and smarter way to redirect both stdout and stderr is by using and okay the starting might want to run a command and completely ignore any potential error message. To do this, we can redirect stderr to a special file called def-none. Um, from this- mm, okay, these three topics aren't as important as I can say. For slightly wide. Again, let's start again. So now we will be learning about pipe and T. Hmm. Let's see what is it. So pipe and T. In Linux, the command line becomes incredibly powerful when you start connecting commands. Instead of running one command, saving its output, and then running another one, you can create a pipeline to pass data directly between them. Understanding the pipe operator. Let's start with a command that produces a lot of output. ls. Yes. Okay, let me see what it does. Mm, ls slash etc uh, slash a. Okay, okay, it has a lot of thing. And now this item, the list of item is likely too long to fit your screen, making it difficult to read. While you could redirect this output to a file, a more efficient method is to send it directly to another command like list for easy viewing. Oh, okay. The pipe operator represented by a vertical bar is the key to this process. It takes the standard output of the command on its left and uses it as a standard input for the command on its right. In this case, we pipe the output of ls etc directly into the list command. The pipe is a fundamental tool you will use constantly. Splitting output with the T command. What if you want what if you want to see the output on your screen and save it to file simultaneously? This is where the T command comes in. The pipe and T command in Linux is a classic combination for logging and monitoring. tpeanut.txt. After running this, you will see output on your terminal. If you also check the content of peanut.txt, you will find the exact same information. The key command effectively split the output stream into two directions, one to the standard output and one to a specific file. Combining pipe and T. You can create even more advanced workflow by changing this command. A command pattern is to pipe to T in the middle of the longer command chain. This allows you to save an intermediate result while continuing the process the data. For example, you can use Linux pipe T command combination to view and save output before further filtering. Let's see. Okay, and then we yes. Okay, this command does switching. And just okay. So now we get it. Okay. So what can we do is we can we can write something ls slash etc and then we will save it to we need t command, right? T command. Let's etc t command etc t file.txt and then get something like that. Okay, t banana txt and then we can even sort what and then it's sort. Okay, we can do sort also. Okay, now it's giving us in sort manner, and if I cat that what was that banana txt. Okay, we have it over here too. So now Okay, this is how it works. That is the basic. Let's put that over here. Environment. T command to uh, put in a pipe to connect different command. ENV. Oh, so in here it's a ENV. Oh. Your Linux system uses environment variable to store information that the shell and other processes can access. This variable contains useful data about your user session, system configuration, exploring basic environment variable. You can view the value of a specific variable by prefixing its name with a dollar symbol. For example, run the following command: path of my home directory. Mm, user. Now, this particular ENB topic is very important since basically when I tried to install React Native in my window, it told me to add a path to my window directory, right? And I was actually very confused how to do that. But here I just clicked while I was reading this, it just clicked to my memory that okay, so this is why we need to add a particular path for any directory. So now let me just do ls and let me try to let me first okay see my enb, right? So this is my enb. So what are here? Okay, first there is my cell name and mm, let's see genome cell session mode ubuntu sss auth sock, I don't know what it is. uh, Desktop session ubuntu, log name rudy, and then home rudy, username rudy. Now user rudy, display 0, old pwd means old working directory. So now let's see what was their other thing. So it says path, right? So let me env and let's grab path. And okay, is this the path? I don't think so. Path must be in capital, so we'll write this in capital. Path enter. Okay, so this is our path. User local sbin. Okay, why is this separated? Let me copy this and let me drag this over here and ask what does means. Oh, okay, okay. Column. It is separating everything by column, right? It was written in that mode. So, how many paths are there? One, two, three, four, five, six, seven, eight, nine. So there are nine paths, and we will be adding our own path here. So let me go back. Let me just see if there is something important in our matter. Earlier directives are source first, no space between path. We record as a separator. An empty entry like user serving means so source the current directory means okay, there is nothing important. Now okay, we need to add, okay, let's add export. Let's add my name equal to Prashant, and now echo okay, enter. Okay, Prashant arrived. Now how to delete this? It will be deleted after I reboot. This says something like that. Okay, now to make it persistent we need to open dot bash. Okay, Turn this up cd slash, let me ls a and ss slash, okay, not cd over here, right, ls a, and go inside this file, not base src. So here is everything, right? So dot, so yeah, I'm exporting to the end of the line, end of the line. So let's use our vim and base rc, or what is the name? It was dot 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 base rc, right? And in the very end, what we need is to add file. We need to add export text, uh, text equal to haha, and let's go exe and let's quit. Okay, okay. Now we need to add source dot base rc enter. And now after this test value will be available in future terminal running like a test echo dollar te st. Okay, so we got it. Now we got it, but we need to. What I wanna do is I want to set this path. Okay, what does an env do? And okay, over here is path. You can view its content specifically with path. This command returns a column separated directory. When you type a command, your system searches through these directories to find the corresponding executable file. To fix this, you can modify the path. Okay, over here. Imagine you manually install a program in a non-standard directory like okay. So this is a command. I want to actually how to do this. Okay, I want to actually do this. Okay, in my current directory, I want to install a program and perform this operation and set the path, set this path to my env path. Okay, current directory, so imagine, okay, this wherever you are right now, add this directly to the path. First, I need to install something and install or place the program, add its directly to the path. Okay, if it's manually installed, not using apt, this usually means copy or move your program there. I'm confused right now. So I I don't know anything about installing. Okay, insert CD. Next step is over here. We will add this. Okay, so we will first make and create a path, and we will copy that command. So we install. This is error not found. This is not found. What I install. Oke, giliran aku. Apa ada pen your path will be telling you when the protest content basic command like this cat echo uses a content most about this Okay, we have added. Okay, so now we have actually used the path and created a new path inside the env. So if I do echo path, then sorry, it's not echo path. Okay, it's echo path. So you can see home Rudy bin and home Rudy bin in small one. These are the bin that we just added. So this is how we add. And when we after we added, then only we got the git prompt command. So that is how you add into sources. Now it loads. Okay, doing the source home Rudy with that bin. Here is the directory. We don't need to this this okay now git prompt still there wasn't any need but still we added. Okay, now we are ready to go to the next command, which is cut. Let's see. We are going to learn a couple of useful commands for processing text. Before we begin, let's create a file to work with. Copy and paste the following command. So the first command we will express cut, which is extra portion of text from a file. Cut by character. You can extract content based on character position using C flag. Okay. This command outputs the fifth character from the from each line of the file. Now just cutting by field or cut F. I think we actually don't need this one. We don't even need this one too. We don't need to be head, tail. We know both of them. Mm, we don't need tail too. We have already learned about that. Expand and unexpand. Let's learn about this. Inconsistent spacing can make text file difficult to read, while tabs are meant to create uniform indentation. Their display width can vary across different editor and systems. This can disrupt text formatting and alignment. Fortunately, Linux provides simple tools to manage this by converting between the tabs and spaces. This beginner Linux guide will walk you through the process. Converting tabs to spaces with the expand command. When you need to ensure consistent spacing, you can convert tabs into a standard number of spaces using the expand command. This command reads a part and replaces each tab character with a set of space characters, printing the result to standard output. I didn't understand anything, so let's copy this entire thing, and we don't need to copy. We'll just copy this message. Commands explain. These two commands are simple but very useful. Expand, convert tabs into spaces, convert spaces into tabs. Why this matter? In text file, tab is a single character but looks like multiple spaces. A different editor display tabs differently 2, 4, 8 space. So sometimes you want consistency, all spaces for read or tab. Expand, expand. Tabs display with apps, spaces. I think we don't know. We don't need this one too. So let's just skip this one. Join and split. In Linux, managing and manipulating text file is a common task. Two powerful utilities join split. Join files by a common field. Join command is fundamental to when you need to Linux join file to sorted file based on an identical first field. For example, imagine you have two files you want to merge, file 1 and file 2. Using join file and file 2, you can combine them easily. As you can see, the file were combined using common first field 1, 2, 3. Then oh, nothing important. Sort command is useful for sorting lines. When sorted by numeric value board cat telephone dog. We have already done this. TR translate command is recognized as a command between news that translate a character from entire national basic character translation. This is also not that important. Unique command is an essential tool for text processing in Linux. It helps you filter and manage duplicate line. Okay, so it will just give me unique line. The unique several options for remote to count the current of each line and see. Okay, so this is okay. So this is the enabling type is a common does two fundamental things for these are WC and NL counting word count, nothing special. And so on the word count or on the line count, numbering line NL and TXT. This is also not that important. Grape we have already discussed about grape. So this was it. So this session was already covered. Most of the topic were already covered in my previous live, and this specific session only covers a little bit of commands, but we discuss more about env command and setting a path for our software to get execute, which is very helpful if in order to install a software that doesn't support apt or something like that, where you manually install it in your directory and set the set a particular folder as a bin folder, and we add the path to the path variable of that certain directory where we install as a bin. So that is how we actually write. And now let's go to Linux directs. Uh, okay, Linux journey, and let's go back. So we have completed two of the Grasshopper level, two phases of Grasshopper level, and we learned about basic and text manipulation. Today we learned about text manipulation. Now we learned about text manipulation. Advanced text manipulation, user management permission. We have already discussed about those regex. So for today it was just this much. Tomorrow it's all about Vim, but we already know about Vim, so I guess we don't need to learn about Vim at all. So for today, the live session ends, and today we learn about env and setting up our path based on the env bin folder. So we will be doing this tomorrow again.